we try to convert a ketone into an ester using peracid. We did the same thing. We converted an aldehyde into ester using aluminium alkoxide. What was the name of the reaction?
Baeyer H, right?
Hmm?
Oh, sorry, ma'am, that was different. I forgot the name.
Children, we just now covered it now. What is the name of the reaction?
MPV.
Huh?
MPV.
Hey, ketone to ester, Raj. Aldehyde to ester.
Perkin.
Arey, yaar, ester, ra. Fission co-reaction. That was the
Yes,
first
sir. Sorry,
reaction
ma'am. I
that we
forgot.
started, na.
Yeah, yes, yes, that.
Okay. So, the similar way, if you want to convert a ketone into an ester, we go for Baeyer Villiger oxidation reaction. See the mechanism of this reaction now. I take a ketone here, RCOR dash plus a peracid I am taking. OH. Step number 1, peracid na, it would have released H plus. This H plus would have attacked the carbonyls oxygen so that you generate RC double bond O plus H R dash. Now in the next step, RC double bond O plus H R dash is there. You would have formed an anion here. O minus OC double bond OR. This goes for an attack. So that you have RCOH R dash is here. This OOCOR is there. What happens? This oxygen's lone pair cleaves in. This R group that is attached to this carbon goes to this particular oxygen, this oxygen that you're seeing right now. And this bond cleaves. I repeat, oxygen lone pairs gets into the bond between carbon and oxygen. This particular R group, we will discuss which R group will migrate and all. For now, this R group is migrating to this oxygen and the bond between these two oxygen cleaves out. Now what do you have? Look at this molecule. I'm having C double bond O plus H R dash, correct? The bond between carbon and oxygen still is existing, O and R. Understood till this?
Yes, ma'am.
Okay. Now we know what should be the next step here. The H plus would have left, isn't it? So if the H plus would have left, you would have formed this molecule. Is this an ester?
Yes, ma'am.
Yes. Plus, look at this molecule that went out. It will be RCOO minus. The H plus that went out would have got combined here to form acid.
Yes, ma'am.
Let's understand what kind of groups would migrate here. The migratory aptitudes are very similar to your pinochle-pinochlane rearrangement. Very similar to pinochle-pinochlane rearrangement here. So we have hydrogen at first, followed by tertiary alkyl groups, bulky plus or effect groups. Secondary alkyl or cyclohexyl, benzyl, phenyl, vinylic, all of them are almost the equivalents here, followed by primary alkyl, cyclopropyl and methyl. Among them, the importance is given to hydrogen, tertiary alkyl groups, secondary alkyl, benzyl, primary alkyl and methyl.
Have a secondary alkyl equal to like benzene and phenyl, ma'am.
Mm. Yes, I'm telling you the very common questions that are asked are with respect to hydrogen migration, tertiary alkyl migration, secondary alkyl, benzyl, primary alkyl and methyl migrations.
Okay.
Okay, pa?
Yes, ma'am.
Yes, ma'am.
So it is not a case that it should be only alicyclic ketone. Even cyclic ketones also does the same reaction. So you can see it is a cyclopentanone here. You are using a peracid. Very simple thing is that just add an oxygen in between. That's what you are doing. Correct? How do you convert a ketone into an ester? I have RCOR. You said it's becoming RCOOR. Then ester. So you're converting a ketone into an ester here. Same logic is happening here. I am having a cyclic ketone here. I am just introducing oxygen in between. Okay, da? So you can the molecule that you're forming is a cyclic ester, alpha, beta, gamma, delta, where you are going to form the ester with the alpha carbonyl and at the delta position to which the O is attached. This kind of a cyclic ester you make, it's called lactone. Okay.
One minute.